Alright, in this video I'm going to work through some example problems. I'm going to work through 4 of them. And they're all going to be this premise. In the following problems, solve for theta, given that theta is between 0 and 2 pi. Alright, so the first example, we've got sine of theta plus the square root of 2 equals negative sine theta. I want to figure out how to solve that. So the first thing is, I want to group all the sine thetas together. So I'm going to add sine theta to both sides. Alright, sine theta plus sine theta is 2 sine theta. Okay, plus the square root of 2 equals 0. Now that cancels out. Basic stuff, we're going to subtract square root of 2 now from both sides. Alright, so I'm going to be left with 2 sine theta equals negative square root of 2. These problems are very contrived, set up to work out really nicely. I'm going to divide both sides by 2. Alright, I'm going to get sine of theta equals negative square root of 2 over 2, which is a problem that we solved before. I want all of my answers in all of these problems to be between 0 and 2 pi. So what I do from here is, now that I've isolated sine of theta, I'm going to use my unit circle to list out all of my thetas. So theta equals this set, and this is how you list a set from least to greatest. So theta equals, let's see, negative pi over 2, negative square root of 2 over 2. So that is going to be at 5 pi over 4. I'm just looking at my unit circle. So that's how we'd get that answer. And at 7 pi over 4. Okay, I wouldn't want to list this in the reverse order. Okay, I want to list all of my set elements from least to greatest. Alrighty, in example number 2, we've got sine of 1/2 theta equals 1/2. Alright, so you might be thinking, if you've already learned this, that I can use a half angle formula. Well, kind of. The problem is, in those half angle formulas, we tend to need like the cosine values of theta and the sine values of theta. And unless we have a reference triangle, which we don't in this case, we can't really do anything with that. So here's how you could solve this problem without a reference triangle, because I don't have one. So these are the only hints I'm given, and I'm trying to find all the thetas that work for this between 0 and 2 pi. Alright, so what I'm going to do is I'm going to use a skill that I remember learning in calculus, actually, is I let x equal 1/2 theta. There's a lot of substitution in calculus, I remember, u substitution, things like that. So I'm going to let this 1/2 theta equal x. Basically, that's a mess, right? So just let it equal x. And then the reason I'm doing that is so then I can rewrite this problem as, what sine of x, what values of x will work for this problem when it equals 1/2. So I'm rewriting this, right? If I just let x equal 1/2 theta, now I've got sine of x equals 1/2. And I can solve for x here, and I can get a bunch of different values. Let's see. On the unit circle, what x values would satisfy that? Let's see, it would be pi over 6 and 5 pi over 6. And I just use the unit circle for that, just like other problems, right? No big deal. Alright, so that's it. The thing is I want all the thetas. Well, theta, okay, was listed here, so if I times 2 on both sides here, if I multiply times 2, I get theta is 2x, right? And that's helpful because I have x values. So if I want to list my answers for theta, all I got to do is take this and times 2, and I get my theta. So let's see. I'm going to list my set, and again, I'm listing it from least to greatest. So my theta is equal, double this, pi over 6. If I double that, that gives me pi over 3. If I double this, I get 10 pi over 6, which simplifies to 5 pi over 3. Alright, so what I did is I took my complicated mess, I said, alright, I'm going to let x equal that, rewrite the problem, sine of x equals 1/2, solve for x, look at your answers and plug back into this. So these two were really key. Those really helped out because I just got this from this piece. Okay, we're going to do something similar with the next example. Alright, sorry about that, I hit the camera. For number 3, I'm going to solve another problem. I'm going to say, alright, what's, actually no, I'm going to use cosine this time. I think that'll work better. Let's see, let's do cosine of 3 theta equal to negative square root of 2 over 2. right? Let's try that one. And again, we want all the thetas that work for that between 0 and 2 pi, all right? So I could try to separate this into 2 theta plus theta, and then use double angles and some difference formulas for cosine, but I wouldn't be able to get anywhere because ultimately I would need the sine values of this. Again, I don't have a reference triangle. So what I'm going to do is the same thing I did before. I'm going to say, let's let x equal 3 theta. And if that's true, if I'm going to let that happen, then theta must equal, let's solve for theta here, divide by 3, which is the same as multiplying times a third. That's 1/3 x. All right, and I'm going to come back to that. So now let's look at this problem. Cosine of x equals negative square root of 2 over 2. And we're going to solve for x here. All right, so using my unit circle, I'm looking for values that work for that. Looks like 3 pi over 4 work and 5 pi over 4. Great. So those two values work. All right, so now I can take this value and I can plug it back in here and get all my thetas. So theta, what's that going to equal? This is my set from least to greatest, 3 pi over 4. If I take this and I multiply times a third, I get, so the 1 would be multiplied times the 3 pi, so I'd have 3 pi on the top, and then 3 times 4 is 12. So 3 pi over 12, 3 pi over 12, but I can simplify 3 pi over 12, right? If I divide 3 by 3, I get 1, so it's pi over, let's see, 4, right? Pi over 4. I should probably write that with the pi in the middle there. Okay, so the first value is pi over 4. And then my other one, let's see, 5 pi over 4 times a third, that's going to be 5 pi over 12. Okay? You might think, oh, I'm done. Sweet, that's awesome. And you're partially right. You're partially done. The problem is, although these are the only values that work from 0 to 2 pi, there are an infinite number of solutions to this problem if we don't restrict the answers between 0 and 2 pi. And so, what I'm going to do is I'm going to look for other coterminal angles from here, coterminal with this or then coterminal with this, that I can then look at, reduce by a third, and list out. And then when I list those out, since I've reduced them by a third, they might be between 0 and 2 pi. If you were to investigate these two angles, my two solutions so far, these angles aren't very big. They're both in the first quadrant. So there's probably some other angles that will satisfy this ultimate equation right here. Okay, so my x values that I've got, remember I'm reducing them by a third, so if I looked at a coterminal angle with this, I could reduce it by a third and it might be between 0 and 2 pi. All right, so coterminal, how do I find a coterminal angle? Well, I'll just add 2 pi to it, so plus 2 pi. And really, if I'm adding 2 pi to this, the easiest way to add 2 pi is by adding 8 pi over 4. Why am I adding 8 pi over 4? Well, 8 divided by 4 is 2. So this is 2 pi. This is equivalent to 2 pi. And why pi over 4s? Well, I've got pi over 4. So it's easy to add fractions when they have the same denominator. So, okay, here we go. This is going to be over 4. 3 and 8, that makes 11. So we got 11 pi over 4. So this is not between 0 and 2 pi. But I'm going to reduce it by a third. So 11 pi over 4 times 1/3 gives me 11 pi over 12. And this angle is between 0 and 2 pi, right? It's just short of pi, actually. 12 pi over 12 would be pi, so this is just short. This is in the second quadrant. I'm going to see how many I can get. So I'm going to continue to take these values. So I want another coterminal angle, and I should have wrote that arrow in a better spot here. Let's see. Show that it's clear. So 5 pi over 4 plus 8 pi over 4 gives me, what's that, 13 pi over 4? Which then I will reduce by a third. Again, this is not between 0 and 2 pi, but when I reduce it by a third, it is 13 pi over 12. Kind of a interesting way of thinking about it, because I would have never thought, oh, you know, add 2 pi. That seems so counterintuitive because my original problem said only give me answers between 0 and 2 pi. The only reason it works is because of this piece right here. All right, so I'm going to keep going because I think there's some more angles. So I'm going to take this one now, and I'm going to add 8 pi over 4, which gives me 19 pi over 4. And again, when I reduce it, I get 19 pi over 12. Still enough room. This is still between 0 and 2 pi. In fact, you might be wondering, how do I know? Well, figure out how many pi over 12s would be too many. Let's see, 24 pi over 12 would be too many. So as long as I'm under 24 pi over 12, we're good to go. Let's keep going. Let's add 8 pi over 4. So that's going to be 21 pi over 4. Reduce that, that's 21 pi over 12. And that turns out to be the last one. If I added any more 8 pi over 12s, let's see, I would have added it to this one. I'd have 27 pi over 4. Reducing that would be too much. So all 1, 2, 3, 4, 5, 6 of these are between 0 and 2 pi. So I've got 6 solutions that work for this one, which makes sense graphically as well. If you think about the graph that one, graph y equals cosine of 3x, and then graph y equals negative square root of 2 over 2, look at where those two intersect, and it'll be at all these locations. All right? Good luck.